Okay, let's continue with another empirical formula determination. But this time let's start with mass percentage. So find the empirical formula for a compound which contains 32.8% chromium and 67.2% chlorine. The first thing I would like you to do is to assume a 100-gram sample, which would allow us to change the percentages to grams. So we would have 32.8 grams of chromium and 67.2 grams of chlorine. Now we work it similar to the iron, sulfur, and oxygen problem. Let's divide both of these by their respective molar masses. Remember, the molar masses are coming from the periodic table for each of these elements. So this will give us a mole ratio, help us establish a mole ratio. Okay, let's get this where you can see. So 32.8 divided by 51.99. So we have 0.63089, and I'm taking some extra significant figures so that I can clearly see the ratio. Okay, there's for the chromium. Now let's do the same for the chlorine. 67.2 divided by 35.4527, and we get 1.89548 moles of chlorine. Now we know that chemical formulas are a mole ratio between elements involved in the compound. So we look at these two mole counts for chromium and for chlorine, and we look to see the ratio. Now I see a 1:3 ratio. If it's not as clear to you, that's okay. Let's take the larger mole number, 1.89548, and let's divide it by the smaller, the 0.63089, I believe it was. Yes. And we'll see what that ratio gives us. See, and it's a 1:3.00 ratio. So this helps us see that our empirical formula is chromium to chlorine in a 1:3 ratio, CrCl3. And if we were to name this compound, it would be chromium 3 chloride, with the Roman numeral 3 being representative of the ion charge of +3 present on the chromium, because chromium here has a +3 charge, whereas the chloride ions have a -1, and we know that compounds made of ions have a net charge equal to 0. Okay?